As in all advanced and disruptive technologies, generative AI or large language model AI is usable for good and evil. And it has valuable attributes to society and civilization and dangerous or potentially dangerous attributes to society and civilization. So one of the ones that I think is going to be an important, immediate, and easily measurable impact of generative AI is the energy used by the enormous data centers and numbers of processing elements necessary to perform generative AI. And that comes in two phases. One is a model training phase where I might collect in terabytes or petabytes of data from the internet and use neural network technologies and very sophisticated algorithms to crunch those into a model. And then that model gets sent out to what's called the inference phase, where I take customer input and I use that to make results with that AI model and return them to the customer. The energy use of this is going to be staggering. Many of you have heard that Bitcoin and cybersecurity mining processes take about the amount of energy that the country of Argentina does. I would expect that in a fully realized AI-enabled civilization, we might do 10x that to run the AI infrastructure. Let's take a little bit of a look at a calculation of exactly how much energy that requires and exactly what the carbon footprint and environmental impact of that might be. This study was done in a sidebar in the paper, and the paper that Vasu mentioned, you can certainly go and download that and see the details. And as all things related to energy calculations, your mileage may vary. There's a lot of assumptions associated with this, and depending upon how hard you step on the accelerator or the AI equivalent thereof, how efficient your drivetrain is, or the AI equivalent thereof, you're going to have very different results. But one reasonable set of calculations is shown here. So the GTP3 model, which is the basis for the very famous ChatGTP system that in some ways kickstarted the current craze in generative AI, it requires 3.14 times 10 to the 23rd floating point operations, or flops. And for those of you who appreciate scientific notation, you know that is a really, really huge number. And this is just to calculate a single model. And we might need to calculate hundreds or thousands of those models. So let's take a look at an infrastructure that would be useful to recalculate that model once a week. We might want to do that, for example, if I had lots of people who were sharing a set of computing resources, a set of servers in a cloud data center. Or I might want to do that in order to take the same model from the same customer, but recalculate it once a week in order to keep the data that's feeding it current. And I challenge you to go to GTP and ask it to tell you about the danger of Chinese balloons. It'll tell you about heavy metal poisoning and danger to wildlife and stuff like that, but won't say anything about surveillance balloons because the model was trained before that news event. And that's a danger consistent across these AI systems. So training the 3.5 model once a week, the calculation is that we might use a certain kind of NVIDIA server, which is called the DGX H100. It's kind of the state-of-the-art computer. It's about the size of a microwave oven. It takes about 8 or 10 times the power of a microwave oven to run that. And in order to recalculate the GTP3 model in a week, we need 195 of those servers, or about 49 racks of them. Each of them draws a little over 10,000 watts. So the total of this, plus the infrastructure to cool and connect it, is about 2.5 million watts. 2.5 million watts at the current electrical grid average of about 0.85 pounds of CO2 per kilowatt hour. That means that we're going to blow 171 tons of CO2 per week out of the smokestacks of those power plants in order to keep that data center running, in order to train that model. That's the carbon footprint of around 1,300 households, or around 5,000 people. So it's a significant impact. And of course, there's going to be thousands of such data centers continuously calculating and recalculating AI models. and then there's going to be thousands or perhaps millions of additional data centers that are taking those models and running the inference that the AI models are used to provide the value that they generate. So the bottom line is this is a very significant energy expenditure, and we better be careful about how we manage that, what the sources of energy are, and what the efficiencies are that we insist on in the infrastructure.